what you're seeing is not a ray-traced Minecraft. It is fully done inside Blender. It is done using procedural geometry and the geometry nodes inside Blender. Don't be alarmed seeing this huge mass of nodes, but we're going to walk through each node and tell you what this node does and why I have used it, right? So first you see this cube that is already done, but maybe it will be better if we start by seeing first how this grid of voxels can be generated. So first, we don't have any cubes. First, let's just disable, let's maybe disable the scaling. Let's maybe just do this and this. So you see that in the sense of the way this is only a cube of cubes. We generate it by having three-dimensional grids. So there is this grid node in Blender, which can generate a grid. And now here with this node, I'm generating only a line of points. So I'm only generating in the Y direction, only generating one, but in the X direction, I'm generating 45 points. So with this grid, I only generate, if I put only this grid onto the geometry node, I will see that it is only a line of 40 or 45 nodes or something like that. So we don't want this, we want this, right? So here there are 45 grid points. Then we transform them, we rotate them, and then we instance onto these 45 grid points, we instance another grid. So for each point, we instance another line of points. And then for now that we have a two-dimensional grid here, onto each of the points of the two-dimensional grid, we instance one more line, but rotated now in another direction here. And this creates us, at the end, it creates us three-dimensional grid of points. We need to release these instances because each point should be an instance of itself. This is an important step here. So the noise will work for each point as an instance of itself. So it won't, if I apply the noise without really releasing the instances, I will just apply the noise on the whole object. So every point will be the same. But when you release these instances, each point is separate instance. So this tells us that I have 45 points like this, 45 points like this, 45 points like this. If we quickly do the calculation, we have 45 times 45 times 45 times 6 faces, right? We have 550,000 faces, 500,000 faces. It's be careful when you're doing these things. If you need more faces, but you don't need them to be rendered, of course, you can use camera cooling. You can use my script or in Blender's camera cooling. I think it will work as well. I'm not sure about this, but check out my video there. So what we can see is that changing this integer will either increase or decrease the dimension of the resolution, essentially, of the voxelization. But I won't push it far here because it will create a huge amount of polygons, right? But now we have created this voxelization, right? So you can do and play around with this kind of thing in different ways, right? Okay, so we need now to instance something onto this voxelization. So now you're seeing cubes, but what if I don't do this? You won't see nothing. So there is this instance on points. So for each point of this voxelization, I'm instancing a cube, and this is the essentially the code, essentially the nodes for a cube. So I have just a value for the combined to a scale, a vector, and then each cube is scaled. I scale each cube by this integer. So like the higher the integer, the less the smaller the cube. I'm gonna make the cube smaller. Okay. And we are adding a material onto the cube, right? Now we have at this point, we have cubes. At this point, we have cubes. Now you can see that I'm just having this point here. Now for each cube, I will do a couple of steps. There is this node translate instances, which will take each instance as a separate instance and will translate. Then I'm releasing it, and then I'm scaling each instance again. But before I do this, before I do these steps here, I have one thing we can do. We can take a noise texture and add this greater than node. So greater than node, what it does essentially, it says if this noise is somewhere greater than 0.5, it is true. If it's not, it is false, right? So I can put this greater than node into the selection here. And now for each cube, you can see it is either true or false. And this only depends onto the noise. So if let's say if I like scale it down or scale it up, it will give me different noise. And then I can here on this vector, I can add geometry information for moving the noise texture in three-dimensional space. But for now, this is good. So we have this node that just eliminates nodes that have noise less than this value, 0.5, right? But now this is true Minecraft, okay? Now we have this version that, yes, correctly, we have eliminated nodes and we have created some terrain. Yeah, wow, wait, right? But we can do even better. We can first translate some instances with some here factor. This will just make the space more dynamic, right? We can then animate how do we translate these instances, so up and down, and we can do some other stuff with this, right? It's not that important. But the most interesting thing we can do is we can scale the instances according to the noise texture. So if I plug this in here, you will see that some instances get scaled down that are like close to the end, close to the border, and some instances that are inside this, that the noise texture is very high, that like the noise value is very high, the size is very high as well, right? You can see that some of them are moved a little bit. So like I have this, like due to the translation, they're a little bit off, and this makes it for just a tiny bit of more realism adding to the scene, right? But how the scaling works, it just gets this from the noise texture. If we follow this line from the noise texture, it goes to the map range node. Then just here I animate some like constant value that I can just tweak around, you know. Then I can animate even a color ramp here. And then I can clamp the values in order to make the scale from 0 to 1. This here's node scale elements takes each individual element, each instance, and it scales it individually, which is which is very important, because if you don't scale it individually, you will have problems. You will be scaling the whole object, right? And then we just release the instances if we want to do some other stuff, and that's it. We can try to play around with these values. You see how playing around with these values change. Now we can see like how we can make it. You see all of these points here are actually what we see in this grid, right? In this grid, the grid will be filled up with points, right? Now we can play around with this constant value and see, whoa, we don't like this. Maybe we like something like this, which is much more, I don't know. Let's render it and see how. Okay, maybe it doesn't look good on renders because it's just so many instances, right? But it's interesting to play around here with like different values. Yes. Now the world is open. You can do tons of stuff with these geometry nodes, and I will want for one more thing from you is to recommend something in the script in the comments section below what we should do next. Maybe we should if there is a suggestion that you want to see me create with geometry node. So hope you enjoyed this short video, and I'll see you in the next one.